Okay, so we have talked about what happens whenever we divide by a monomial. So now we need to talk about what happens when we divide by anything else. This could be a binomial, trinomial, it could be any polynomial. And actually, this will work with monomials also. It's just that there happens to be a little bit of a shortcut that we've already talked about with those. Alright, so when we divide by anything other than a monomial, we have to do regular plain old long division. So that means that we have to write it out as x squared plus 5x plus 6 divided by x plus 2. Now, as we do this, this seems a little bit daunting, so what I want to do is I want to go back to just a plain old division problem. Let's say that we had something that could be kind of big, like 72,435 divided by 62. Now, we don't know how many times 62 goes into this off the top of our head, so we have to do it step by step to figure it out. So let's do just a few steps of this problem, and let's really pay attention to what we're doing so we can apply it to our polynomials. Okay, so to start with, we always say, okay, 62 won't go into 7, but 62 will go into 72. Then we have to say, okay, how many times will 62 go into 72? Which is another way of saying what times 62 will give you 72. Well, it's not exact, but we can get close because it will go in one time. Now we multiply diagonally. 1 times 62 is 62. We write that answer down here. And then normally we subtract. So 72 minus 62 would be 10. And then we drop our next term and we begin all over again. We say what times 62 will give us 104. Well, it's not exact, so we have to get as close as we can. And that would be a 1. Then we multiply diagonally. 1 times 62 is 62. And then we would subtract. So we would have, what, 42? And then we would drop our next term and begin all over again. So this is just a repeated process of doing the same thing over and over and over. Well, we apply this now to polynomials. And actually with polynomials it's a little bit easier than it is with these because we can get exact. We have to say what times x will give us x squared. Well, that would be x. So I'm going to write x. I'm going to keep everything nice and lined up. This would be my x squared column, this would be my x column, and this would be my plain numbers column. Once we have our number up here, just like we put the 1, then we multiply diagonally. So x times x plus 2 would give us x squared plus 2x. And then we would subtract. When we're subtracting polynomials, we have to subtract every single term. So what I'm going to do is basically change the signs and combine like numbers because that's the same thing as subtracting. So our x squareds cancel out. We have 5x minus 2x would be 3x. And then just like we did here, once we subtract, we would drop our next item or our next number, term, whatever, and start all over again. So x times what would give us 3x? Well, that would be a positive 3. And now we multiply diagonally. 3 times x plus 2 would be 3x plus 6. And then we would subtract, which means we change the signs and combine like terms. So 3x minus 3x is nothing. 6 minus 6 is nothing, so we have a remainder of 0. So our answer here is x plus 3. That is the answer to that division problem.